Here is a very comprehensive list of trigonometric expressions, and I have compiled these examples for you so that you can practice solving expressions and thereby get prepared for proving trigonometric identities. Trigonometric expressions are important since, if you see, when we prove a trigonometric identity, we are trying to prove left side of equality to the right side or right side of equality to the left side. Each in itself is just an expression, right? So if you know how to solve or simplify an expression, you should be very good in proving trigonometric identities. So here are quite a few for you. Now make a note of these and try it out. Now I have given the topic as trigonometric identity communication. Well, mainly because even to simplify these expressions, you need to do or apply some known facts. For example, the very first one says sin x, cos x and tan x. Now when you multiply them, it can be simplified. Now for that, you have to use the quotient identity, which is tan x equals to sin x over cos x. So while you are doing this, I expect you to write the identity which helped you to solve this. It will really help you to get into trigonometric identities. Okay, so these expressions will be very beneficial for you. Now the next one, for example, is sin x plus cos x whole square. Now if you use a plus b whole square formula, for example, then you can write a plus b whole square is a square plus 2ab plus b square, and then if you're using the Pythagorean identity, you can write that on the side saying, well, we got 1 since sin square x plus cos square x is 1 from Pythagorean identity. So likewise, it'd be a good practice to write on the right hand side all the identities which helped you to simplify the given expression. So make a note of all this and then try them out. In case there is a difficulty, you can always go back to the resource which I have created with about 100 trigonometric identities solved, right, and expressions in them. So they will definitely give you something very close to what you have, and so you can always solve them. Or if you have any other question, you can always write to me or write your comments, post your comments, and then I'll look into it, right? So make a note. This is sin x, cos x, tan x, a simple expression where you can split tan x as quotient of sin x and cos x. Now cos x will cancel out. You're left with sin x. Then we have sin x plus cos x whole square, cosecant square minus cot square, square root of 1 minus cos square x, cos x sin x divided by cot x, sin x over cos x plus cos x over sin x, cos square x theta sin square theta plus cos to the power of 4 theta. Here you can factor cos square theta. Cos to the power of 4 theta minus sin to the power of 4 theta. You can use difference of cubes. 1 over sin x plus cot x. Write cot x as cos x over sin x. 1 over 1 minus cos x plus 1 over 1 plus cos x. Take common denominator. 1 plus cot square x divided by cosecant square x, 1 plus cot x divided by 1 plus tan x, tan cube x over 1 plus tan square x, sin x plus tan x divided by 1 plus cos x. So in most of these identities, even if you write tan x equals to sin x over cos x and then use the identity sin square x plus cos square x equals to 1, you should be in a position to solve, right? And I hope you remember difference of squares. A square minus b square is actually equals to a plus b times a minus b, right? So we don't have any cube here, but in any case, you'll have those in the worksheets. So try these out and then start solving or proving the trigonometric identities. Thank you.